Okay, so we're going to get into the issue of redirection and streams and stuff at a very brief level here, folks. So it turns out that a lot of commands then take information from certain standard places. We mentioned those places last time. So-called standard input. That's a place a lot of things look for their input by default. You don't give them a file name, they'll look for the standard input. So, for example, I can say, ladies and gentlemen, I can say here, I can say, let's go find something here. Cat dot, cat foo. I don't know what foo is. Oh, it's a directory. Okay, I want cat that. I can cat v1.mw. This is going to be some god-awful thing. I can cat that, but if I don't say anything, if I say display this stuff, where's it going to go for that? In other words, if I say cat a file, it goes and it says, yes, sir, and it goes and it grabs the content of that file and puts it out. That's what it says to me. If I just say cat by itself, and this is a very standard thing in Unix, if I just say cat, where's it getting its information from? It's getting it from standard input. It's getting it from standard input. And what is standard input? It's whatever I type here. So I could say foo, bar, baz. Why is it appearing twice? I can assure you I'm only typing them once. I'm not an Olympic typer. Foo, bar, baz. Why is it typing them twice? One is the input and one's the output here. One's coming in from me. And as soon as it receives that, it says, I got to print this out. It prints it out. Does that make sense? So I type foo, it prints foo. Type foo, prints foo. Okay? So here, I can be typing this out, and it can be typing this in, and it is processing it all along. Remember we talked about that a little bit last time when I introduced this notion of types, because I said that it's actually doing this live. It's running that command live as I type things in. It's processing as much as it can get. And it may pass them to other things, like things that sort them, or things that look for unique values or whatever, and print things out all along. So, for example, I could do cat, and I could pipe it to unique, it turns out. In other words, take the output from cat, the standard output that it puts out, and give it as the standard what to unique, as the standard input to unique. So here, I'm taking the output from whatever cat gives, and I'm giving that to this file called unique, which looks for, what do you think? Unique lines. So I could say, foo, and it prints out foo. Who's printing this out? Is it cat now? Unique. How if I say foo again? I could say foo again. Why isn't it printing out two foos anymore? It's not repeating. It's only printing out the unique ones. I could say bar. Will it repeat it now? Yes. Indeed. And I could say bar again, and it won't repeat it. And now I could say baz. Will it repeat? Yeah. And just to complete the example with the canonical sequence, you get foo, bar, baz, and what's the next one? Zap. Zap is indeed repeated. So what's happening, folks? So here we have cat taking input from me, taking as its standard input when I'm typing it. As soon as it's taking that, it's passing it off, sort of like a bucket brigade. It's passing that off to unique and waiting for the next one, right? Waiting for that next one. Passing each one off in turn. Unique, meanwhile, is saying, is this the same as the last line? If so, just ignore it. If it's a new one, I'll print it out. And that's what I'm getting. Does that make sense? That makes sense. Okay. So here we have a thing called piping going on. And that's one way to use this kind of so-called redirection. redirection in the sense that I'm taking the output from cat and I'm redirecting it to something. But another thing I could do is I could put it into a file. I could say cat into 214 cat example. I don't know. And I could say foo bar baz zap. And now to finish this, I press Control D. Okay. By convention, that finishes it off. That's the end of file character. Control D. Mark my words. And now if I want to see what's in this, if I want to see what's in this file now, how do I go see it? Tell me a way to go see what's in this file. I want to see what's there. I could VI it, yeah. Or I could do ls. First of all, I could see how big it is. By the way, I'm going to type this and I'm going to press tab and it will tell me how I can finish it. I'm going to press one more C and I just pressed tab. Did you get that? So I did this, I'd say 214, and I pressed tab. What is it doing here? It's showing me all possible completions. And then I could say cat, and there's only one of those, so it completes it all. I could say ls minus l. Okay, so ladies and gentlemen, this is 16 bytes long. Total up, foo, bar, baz, zap. Each of those is 3. And 3 characters, so that makes 12. Where are the other 4 characters? New lines between them. It's the fact that this guy's on a next line from that. It has to communicate that. They're on different lines, so it has to tell it somehow, and it inserts a special character called /n. Wow, so it's a new line character. We denoted C as /n. It's a new line character. So it's a length 16, but how do I want to see the contents? How could I see the contents? I could more it, or I could do cat it. I could do cat example, right? And there it is in all its glory, right? Or I could more it, right? It's not large enough to really make a difference. It's where pages, you know, if you just see pages of this stuff, but you know, this isn't enough. It's a small enough file. You can just look at it. Okay. So the point is here, folks, when we have these commands. They take in things. So here we have cat. They take things in from standard input by default. We can give cat a we just did. We just gave cat in this latest thing. We gave it a file name. Right? We said cat that. But by default, where's it going to come from? It's going to come from standard input wherever or from it. If we didn't provide something as standard input, didn't provide something for it, it's going to be looking for us to type it. And then it's putting out to standard output. And in this case, originally we sent it off to unique, or later we sent it to a file, which we call 214 cat example. Okay? So here we have standard output, standard input. By the way, another way to get it into cat as standard input would be what? If I wanted to cat that file, instead of just saying cat the name of it, if it wasn't able to say the name of a file here, how could I get it to print the contents of this in a clever way? I could say take it as standard input. Take this file and give it as standard input. That's what this less than sign means. It means like take whatever's in this file and put it in as the standard input. So I could say cat it, and I'll get that, okay? Or I could say unique this, and I'll get that out. Or I can say word count it, and I'll get that out. Okay? 4 lines, for example, 16 characters. Four different words. That's what word count is giving me. So I can take things in from things as standard output, put them out to standard output. So just to sort of, so we're back to this. Okay, another thing you can do is if you want to append to a file rather than override it, you could do greater than log, not just greater than log, you can do greater than. So if I wanted to, so what would this do, folks? What would this command do? Cat, what does this less than sign mean? It's going to take its standard input from source, and what is this going to get it to do? It's going to put its standard out in a file called dest. Okay? In short, it's kind of a long way of saying copy the contents of source to dest. I'm not quite sure how it handles Unicode, all that, if there's any issue with that. But in any case, it's going to copy basic contents from source to dest. Okay. Okay. So let's talk about these a little more. So with redirection, you got to be careful because you can overwrite. You can overwrite treasure files. You can overwrite your notes when it's comes. And so there's ways to prevent that. So you'll notice you can do, you can set what's called the no-clobber option within Linux. So let me demonstrate for you the dangers associated with this, okay? So now we have this cat example, but let's suppose I were to do 214 cat example. I'm now overwriting it. Foo, bar, I'm going to repeat bar twice. Baz, I'll repeat Baz 3 times. Zap, just once. I just overwrote the original file. It didn't warn me. It didn't let me know there was a file named that name. And you could be at risk from that. So, ladies and gentlemen, so one thing you can do is you could do set -o no clobber. Okay? Set -o no clobber. And then when you do this, it will say cannot overwrite existing file. And you can say, look, I really know what I want to do. You can use this command here. That's greater than sign right next to a vertical bar. Okay? Say, I know what I want to do. I want to do it anyway. Okay, so then I could type it to my heart's content. Okay, so in short, it is possible to set a no-clobber option so it won't allow it. And this is a classic command, ladies and gentlemen, that you might want to use every time you log in. Instead of logging in every time and typing this every time, forgetting to type it sometimes in the grid. You could set this in your profile to execute. You could set it in your .bash or C, and it will, that's one of the things it will do to set up your preferences. You can configure that as you see fit, okay? Just bear in mind, you don't lose the liberty of doing it. You just have to be quite explicit about it by doing this greater than vertical bar, okay? Okay, it turns out that standard output is not the only stream that can come out of a command in Unix. There's another stream called stderr. Okay? And if you have a command, I don't know, if you're running awk, as you'll run later, and you're taking things in from standard input and putting things out from standard output, it will, so this may be standard out, and this will be standard in. You notice my use of time-honored abbreviations there, stdin, stdout. There's another one called stderr. Okay, and this is a separate stream. It's a stream to say bad things are happening. You got to know about it. These bad things are happening to me. Hopefully you can fix them for me as the user. So if awk is getting confused, you're going to give it a little program in awk to look for things. And if it doesn't know what that program means, or if it's obviously malformed, it's going to be compliant. And it does that on stderr. Okay? So here you can actually grab that as well. Visually, that might look mixed in with standard out, but you can put that in a different place by using this we actually say 2 greater than file name. And that will, if you just said greater than, just greater than, it would put the standard out in the file name. 2, it'll put standard error in the file name. And you can do both simultaneously. So, if I wanted to, if I wanted to, I won't show anything fancy. Suppose that cat actually, we're saying so I could get, this to my standard out, and I could do 2 to my standard error output, output from cat, so output, and each of them, if there were an error message generated, it would put it out to this file instead. For example, maybe I'm asking it to cat a file. Watch this. So cat foobar, and okay, yeah. So I did the no clobber. Okay, fine. So how am I going to fix this? How am I going to fix it? Okay, I can do the bar here. Do the bar here. Okay, so I just said cat foobar. Now, there is in fact no foobar. Despite my frequent use of that, you might think it's one of my favorite files. So now I can go look at what's in my std out output, and I don't see anything at all. But if I look at my stderr output, what should I see? No such file or directory. Why does that appear in there? Because that was the error message that cat gave. It is what's in the file. But the reason it's in the file is because that's the error message which cat gave to print out when I said cat foobar. I couldn't find foobar. So I can't find this file. And that error message got put into this file because it had this 2 greater than in front of it. Does that make sense? So the error message goes there. Normal messages go here. Okay. And in fact, cat allows you to do multiple things. So you could say cat foobar, and then I could ask it to do what was a previous one that I've had here, v1.mw. And I could do this, and you'll notice that here my stderr output will complain about this. The other file, my stdout output, will have the contents of that thing I piped into it. So in other words, here it complained about this, but it processed this next file. The complaints went here. The regular output, ladies and gentlemen, went there. The regular output, in short, ladies and gentlemen, went to what? It went to, the regular output went to standard out, and the error output went to stderr. Yeah. Okay, does that make sense? Okay. Okay. So I talked about configuration files. You'll notice that there's this .profile file which can be used. Okay, there's a history buffer that allows you to sort of repeat the last command very easily. So if I do ls minus l, la, and then I want to repeat it, I could do exclamation point, or I can say I want to repeat it, the latest command that had like a cat at its beginning or had C at its beginning, and I'll do C, and it will do the latest one that had that. Okay. Okay. So command name completion is available on tshrc and bash, and you might really want to use it. Start typing, then type the tab character. It can work for commands. It can work for file names, and by default it's on. And you can also use Control X in bash to get sort of completions. I don't have time to go into this because I want to get to a final set of material that you're going to want for the lab, okay? So forgive me for going through this a bit quickly. The slides should be available. I think they're fairly self-explanatory. So let's talk about the state of the shell. I want to talk about the state and I want to talk about permissions. Okay? Those are the two key things I want to cover stuff. So now is a good time to nugget out.